Hi, welcome back. On today's lecture series, we are going to discuss about the comparison of Gauss Seidel and the Newton-Raphson method for power flow analysis. So normally an Gauss Seidel and Newton-Raphson method, which is used for the load flow problem solution. So here for the determination of the steady state operating conditions, for determining the bus voltage and the angles, and to find out the power flow in the transmission lines, and in order to determine the system losses in the transmission network. So here, why we have to compare the Gauss Seidel and the Newton-Raphson? It is mainly to compare the speed, the convergence speed, and how the computational will be complexity, and what is the memory requirement by the Gauss Seidel and Newton-Raphson, and what is the reliability and accuracy of Gauss Seidel and the Newton-Raphson method. So for these reasons, we have to compare these two methods. So at the empathy stage, we are having a lot of questions. How we have to understand what is the convergence, what is the behavior of convergence, and how many iterations has to be calculated, and how much it will be fast, and what is it is whether it's a reliable or irreliable solution, and how we have to handle the large network, and what about the accuracy and the tolerance, and whether it's suitable for real time or not. So we are having the n number of questions in the empathy stage. So from this stage here we have to clearly define. So what we have to do? Here we have to solve the nonlinear algebraic power flow equation efficiently. So for this we have to balancing the speed as well as the reliability for different system sizes. And in the ideate stage, here we are going to compare the Gauss Seidel and the Newton-Raphson method. The Gauss Seidel method is sequential iteration, and it can be used with the latest values immediately. So the implementation is also very simple when we are compared to the Newton-Raphson method. But the Newton-Raphson, it is simultaneous solution. We are getting the solution simultaneously, and we are using the Jacobian matrix for the formation of matrix, and it will be quadratic convergence. So here the Gauss Seidel, here the algorithm we have to follow the step-by-step algorithm. So here and the Gauss Seidel, the first step here we have to initialize the voltage. So here we have to assume the voltage as 1 per unit. So and after that we have to calculate the bus powers. That is nothing but in real power and reactive power for the specified values of buses. And the third one, we have to update voltage sequentially, whether the system voltage is within a limit or not. We have to check the limit always. So here we have to use the Y-bus formation for a number of iterations. And after that, we have to check the convergence. So the determined value of the voltage, which is less than the tolerance or not. So once it's done, we have to go for the next step, and we have to repeat until the convergence is occurred or the maximum iteration is reached. So in the Newton-Raphson method, we have to start the program, and we have to define the given value, and we have to initially estimate what is the reactance and what is the angle value and what is the maximum value, minimum value of everything, and we have to run the loop for all all the number of loops from I is equal to 1 to the maximum value. So in order to determine the x1 parameter that will be given, so whether it's within the tolerance level or within a level or not. So whether it's convergence is done or not, convergence is done, we have to print the solution and we have to end the process. Otherwise, so we have to go for entire loop system until the convergence is matched. So this is the detailed comparison. So here the convergence rate is very low, or it may be linear in the Gauss Seidel, and in the Newton-Raphson is very fast. And the number of iteration in the Gauss Seidel minimum from 20 to 100 plus, and the Newton-Raphson it requires from 3 to 5 iterations. And the memory usage for the Gauss Seidel is very low, and Newton-Raphson we are, because of using the Jacobian matrix or Jacobian storage, the memory usage is high. And computation and iterations, the Gauss Seidel is simple and Newton-Raphson will be complex. And the initial Gauss sensitivity is moderate in the Gauss Seidel and critical in the Newton-Raphson. So for the Lissam's parameter, poor or mean or convergence, and it will be excellent in the Newton-Raphson method. And the programming complexity is simple in the Gauss Seidel and moderate in the Newton-Raphson method. So this is the prototype. We can take the IEEE 5-bus system, and you can take the 7 buses among the IEEE 5-bus system, and out of 5 buses, the 2 is generator bus. So here there are 32 iterations in order to converge, and the tolerance level, execution time, everything can be calculated. And for the Gauss Seidel, and similarly for Newton-Raphson, so it requires only 4 iterations, and this tolerance is same, execution time is given. And this is a real-time application. It can be used in the energy management system along with the SCADA and distribution networking and the renewable energy integration. So this is a mind map summary. Here the load flow problem, whether it's linear, non-linear, everything can be studied, taken as the input, and we have to use the Gauss Seidel and Newton-Raphson method, and we have to compare the both with using the speed, simplicity, memory, and we can know the applications. So this is a curative challenge. Can you modify Newton-Raphson to reduce memory requirement? So put your answer in the comment section. And this is another assessment. So if you know the value of, if you know the answer for this, just you can put in the comment section. And these are the few textbooks and the references can be useful for this topic. Thank you.